So today we're going to cover Chapter 5, Section 5. We're going to learn 2 more shortcuts to prove triangles congruent. And the little acronyms for them are SSS and HL, which stand for side, 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 and hypotenuse leg. So first we're going to talk about the side, 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 or SSS Congruent Theorem. And this just states that if 3 sides of one triangle are congruent to 3 sides of another triangle, then the 2 triangles are congruent. So what you're going to need to do here is to match and make sure that all 3 sides have congruency marks on them. So for example, in this picture, I can see that side AB has the single congruency mark as well as DE. So in your proof, you would have been stating that AB is congruent to DE. This may be given to you. You may have to establish that it was a reflexive side if they're attached. It'll be different reasons. But our goal here is to show that all 3 sides can match up. Then I'm going to go here to the side that has the 2 marks, and I could state that BC is congruent to EF. And then the last side that's got the markings are going to be the AC, and it's got 3 to the DF. So AC congruent to DF. If you're asked to write a congruency statement, the order will matter. It doesn't matter what you start the order for the first triangle. I always like to try to make it in alphabetical order. So the first one I'm going to say is ABC, and then I'm going to match the second one. So notice how I put in red there, the AB is congruent to DE. So then when I go to match this one, DE will be my first one, and then obviously the last letter there is F. So be able to write a congruency statement as well. Most of the time when I give this on a test, I'm going to start out and I'll say ABC is congruent to blank, and then you'll fill it in. When I first started teaching this, I made the mistake of letting everybody write their own congruency, and then I would have 50 million, not 50 million, but a lot to check, because some people might have started theirs with triangle CBA, and then I'd have to figure out that the triangle that matches with that would be FED, or if you did BCA, and then there was so many different answers. So now what I've learned is I always start out by giving you this, and then you have to tell me what precisely matches with it. First example, it says decide whether the congruent statement is true. Now remember, it's got to be in the correct order or it wouldn't be true. So let's go through and check. So I could go through in the order that it's listed here. It really doesn't matter. I could go ahead and take the first 2 letters, DF, and I'm going to make sure that the first 2 letters in the other triangle have the same mark. So DF has the double mark here, and so does HJ. So far so good. So in my proof I would have stated that DG is congruent to HJ. DG or DF? I'm sorry, DF. Thank you. DF is congruent to HJ because they both have the same mark. Next, I'll go to the last 2, FG, and again, it doesn't matter the order you list these, and make sure that JK has the same mark. So FG has 1, 2, 3, and so does JK. So that one works. And now I got to just check the last side, and that last side has D. I can go here from beginning to end, D to G, and H to K, and it has the single mark, so I'm good. So DG is congruent to HK. So because I showed that all 3 sides matched up perfectly with the same type of congruency mark, I could say that yes, this is a true congruency statement. Now, sometimes it'll be marked with congruencies, or it could have numbers. And again, we're just looking to see that these sides that are congruent actually have the same measure, the same length. So that's what we're going to do in example 2. We're going to match up the numbers now instead of congruency marks. So So for example 2, this time we don't have congruency marks, but we have numbers. So let's go ahead and see if this is a true statement. So again, let's take it 2 by 2, 2 letters at a time. So CA and AC, that's actually this reflexive side here, right here in the middle. So I could say, yes, AC is congruent to CA. It's the same segment. And 9 equals 9, so that one was good. Now let's go to the next 2 letters, CB and AD. CB has 7, and so does AD. So far so good. So CB is congruent to AD because they both have a length of 7. And now the last one I need to check, I could go from beginning to end, AB. See if it's congruent to CD. And AB is 3, CD is 4. These are not the same length. So this is a false congruency statement because all 3 sides are not congruent because 3 does not equal 4. Sometimes your pictures will be sharing a side like this. Other times maybe they might overlap, and we're going to see that coming up in our proof, where still they're sharing the same side, and again we would bring in reflexive into our proof. So again, we need to make sure that this is in the correct order. So again, if I take it 2 at a time, QP and RS, QP, RS, QP has the double marks here, and so does RS, so far so good. Then the next one I can go here to the PT and see if it matches with ST. So PT has the 3 lines here, and so does the ST, so that one's good. And now let's check that last one down here at the bottom, the QT and the RT. And it has the same markings. So this is a true statement. And I would be using side, side, side to prove these 2 triangles are congruent. It's like a real world problem, and it says explain why the bench with the diagonal support is stable while the one without the support could collapse. So whenever you have 2 congruent triangles put together, that is going to be a more stable situation. So notice what we've got here is this triangle that's here. Let me see if I can show a color that's going to show up. So this triangle that's right here is going to be congruent to this triangle that's right here. So what you would be given is that the sides of it would be congruent. This side congruent to this, and then the top, and then you would have the reflexive side. So anytime you have a support through there making 2 congruent triangles, this one on the left would be more stable. And we could state this by side, side, side congruence. This other one over here would wobble because there's no support holding it together. So it could like wiggle a little and shift side to side. All right, next. So here, before we can start talking about this 3rd shortcut that we're going to learn, we need to know the parts of the right triangle. So the 2 sides of the triangle that form the right angle are called the legs. So these 2 are forming, they form the right angle. The hypotenuse is always directly across from the right angle, and it's always the longest side of the triangle. Now, The shortcut or the acronym for hypotenuse leg is just 2 letters long. It's HL. Notice the other 2 that we've already learned. The SAS, we had to show a side, an angle, and a side as congruent. And then for the side, we just learned that we had to show all 3 sides are matching up and congruent. Here it's only got 2 letters, but we're still establishing 3 things. We're going to establish that the 2 hypotenuses are congruent and the 2 legs, but the first thing you're going to need to look for is this only works, this hypotenuse leg, for right triangles. So that'll be the first thing you're going to look for, is to make sure that you're dealing with a right triangle. After that, then you're going to look for the hypotenuse in the leg to have congruency marks. So we're still looking for 3 things, even though it's only got 2 letters in the name. Okay, so HL only works for right triangles. And let's see what the HL theorem states on the next slide. So the hypotenuse leg theorem states that if the hypotenuse and a leg of one right triangle are congruent to the hypotenuse and the leg of another right triangle, then the 2 triangles are congruent. Again, it is only for right triangles. Okay, and then we're looking for only 2 pieces of congruence once we see that it's got that right angle. I'm going to go ahead and draw 2 triangles here for you, and then add in everything we need to look for. So if I have my first triangle, I'm going to call this one A, B, C. Again, remember it needs the right angle. I'm going to draw another one right next to it. I'm going to call this one D, E, F. And again, it needs the right angle. So the first thing we need to look for hypotenuse leg is that we do have that right angle, and we do. The next thing we're going to be looking for is that the hypotenuse has a congruency mark. And again, remember the hypotenuse is across from the right angle. And then the third piece is that one of the legs. It could have either been marked on BC or EF, or it could have been the AB congruent to DE. It doesn't matter, as long as one of the leg pairs. So let's go ahead and just state everything that we have here. We would end up stating that the measure of angle B is equal to the measure of angle E, because they're all 90 degrees. So the first thing we're looking for is that we have a right angle. The next thing we're going to do is show that the hypotenuses are congruent. So AC is congruent to DF, and this is the hypotenuse. And then the last one, at least show one of the legs. It doesn't matter which. It could have been, like I marked in the picture, BC congruent to EF. That's a leg. Or you could have also had markings on AB and make sure it was congruent to DE. This one's also a leg. So you don't need to do both legs, only one pair. So then I could state, and the order matters, that triangle ABC is congruent to triangle DEF by hypotenuse leg. Because I've established I have a right angle, the hypotenuses are marked, and the leg. So that's how I could use hypotenuse leg. And the order of this statement matters. So notice that middle letter on both B and E, that's where the right angles were. And then from there, you could match up the sides. Notice BC had the single mark, and so did EF, and those were the last 2 letters. The next example is going to be like the question you're going to do in the homework tonight. You're going to be given ordered pairs like this, so I'm going to want to see you graph it and show all the work. So really, in the homework tonight, when you get to this last question, This is really the only one that you have to show work for because all the other ones are going to be dragging and dropping. They're all proofs. So what we're going to do here is I'm going to graph the two triangles. I'm going to do the JKL in blue. So I'll do this one in blue, all the ordered pairs in blue, and we'll see what it looks like. So ordered pair J, and my graph doesn't go quite as long as it needs to get L on here, so I'm going to go a little bit off. But J is -3, -2. It's right here. K is 0, -2. But L goes off a little bit. So if this is -7, I'll say -8 is about here. So I'll come over here, connect my points, and form my triangle. So that's the first one. And then I'll do the next one. I'll do it in red, RST. So R is at 10, 0. S is at 10, -3. And T is at 4, 0. Connect my points. Now, these two triangles, I need to test out to see if I can prove them congruent either by side, side, side or hypotenuse leg. Now, since I have vertical and horizontal sides of these triangles, I can just connect the points. So here I could just see that JK, I can count the little boxes and it's 3. JL, it's got 6 little boxes. Same thing on the red one. This is 3, this is 6. However, for the diagonal side, I'm going to need to do the distance formula. Now, if you remember back when we did the slope chapter and perpendicular, remember a vertical line and a horizontal line are perpendicular. So actually, I've got a right angle right here. And since this side is congruent to this side over here, and this one is congruent to this, I actually have enough without doing the distance formula, and I can say that these two triangles are congruent by hypotenuse leg. But let's just double check, and let's see if LK and ST are also congruent. And then just to show you that sometimes you can use more than one congruency. We could have also said that this is side angle side. So if you've got both legs here marked, actually we have to show that the hypotenuses. Right now we only have the legs congruent. So I can't show hypotenuse leg yet. I got to double check that ST is congruent to LK. But right now I have enough to show side angle side here. So let's go ahead and do the distance formula. So I'm going to do the distance of L to K. So my order pair for L is -3, -8. K is 0, -2. Let's do the distance formula. Going to subtract 0 minus -3 squared plus -2 minus -8 squared, all under the radical. This becomes 3 squared. This becomes -2 plus 8, so 6 squared. So then I get 9 plus 36, which is 45. Got to break down the 45. 9 and 5. So this becomes 3 square root 5. So the length of this hypotenuse is 3 square root 5. Now I'm going to do the red one. I'm going to do the length of ST. The order pair for S is 10, -3. For T, it's 4, 0. So again, I'm going to subtract 4 minus 10 squared, 0 minus -3 squared, all under the radical, -6 squared, plus 3 squared, 36 plus 9, same thing, 45. And again, this one is also 3 square root 5. So now my hypotenuses are also congruent, and all 3 sides are congruent. So I could actually prove these two triangles are congruent by hypotenuse leg, side, 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 and side angle side. So I could actually have done this using all three of the shortcuts I've already covered. Now again, if they ask you to write a congruency statement, the order matters. So I'll start with the blue one. I'm going to start with JKL, and I'm going to state that this is congruent, and the order matters here, to RST. Notice where the two right angles are the J and the R, and that was my first two letters. And then from there, go down one of the sides to get your third letter in its place, or your next two letters. So these are actually congruent by all three methods. So when you're doing the homework tonight, you're going to show the work and come up with one of the shortcuts that'll prove the last question are congruent after you graph them and do the distance formula. Yes. So example 6 here, it says, is there enough information to prove the triangles are congruent? If there is, state the postulate or theorem. So I know it's kind of hard to see, but again, it doesn't matter with your statement. So actually what's here is F, G, H, and then H, J, K. So let's go ahead and see if we've got enough information. Notice they both have right angles. They both also have the hypotenuse, which is the side across from the right angle, marked as congruent. And then we also have a leg that's marked as congruent. So we could say, yes, these two triangles are congruent. And my reason is hypotenuse leg. Now remember, these triangles are not always going to be facing and sitting the same way. This is where it gets a bit challenging. So what's going to be important is you match the congruency marks or you're matching the numbers. So this has enough information. I marked the right angles. I saw that the hypotenuses were congruent and one of the leg pairs. Now we'll do a proof and then we're done. So it says to write a proof. So it wants me to be able to try to prove that this triangle over here, the WYZ, is congruent to triangle XZY. So you see how they're overlapping? And they're actually both sharing this same side here, the YZ. Now I've actually pulled them apart. So here is the blue one. And here is the red one. And I actually even flipped the red one away so you can see the matchings a little bit clearly. All right, so let's go ahead and start by putting in all of our given. So we are given that WY is congruent to XZ and that WZ is perpendicular to ZY and that XY is perpendicular to ZY, and all of this was given. Now notice when I labeled my picture here, I put in the congruency marks on the hypotenuse. So I labeled that WY was congruent to XZ. I also added in the right angle, but I still need to establish that in my proof. The reason why I could draw this right angle here is because these lines are perpendicular. This is what was given to me. So the right angle is right here and right here. So I need to state that in my proof. Now, if the two triangles are given to you pulled apart like this, you can just say angle Z and angle Y are right angles. But if you don't pull it apart and you leave it like the original picture, when you write the two right angles in your proof, you're going to use 3 letters. So I need to state that it's actually WZY and angle XYZ are right angles. Now, if the pictures were like the single ones that I did, instead of saying this, you could have just said this is angle Z and this is angle Y. So right here and right here, if they're pulled apart. And the reason why I can state that they're right angles is definition of perpendicular or perpendicular lines. Next, I'm going to establish that it's a right triangle. So because it has a right angle, I could say that WYZ and triangle XZY are right triangles. And this is definition of a right triangle. So I've got a right angle. I was given that the hypotenuses are congruent. And now I just need to show that the leg is congruent. And remember, this leg is this one that they share. See how it's ZY here, but it's YZ here? So this is the same leg. So I can say that this is congruent to this, and my reason is reflexive. So I could either say it is just ZY. If you want to put it in the order that you see it individually, you can say ZY equals YZ, or you could say ZY congruent to ZY, either or here, and this is reflexive. The order doesn't matter when it's a segment. And then the last statement is what you were trying to prove, because we've got the right angle, we got the leg marked as congruent, and the hypotenuse. So last step, triangle WYZ is congruent to triangle XZY, and this reason is hypotenuse leg. And that is it for the notes on 5.5.